This video is about non-renewable power sources. We'll be looking at coal, oil and natural gas, which are the fossil fuels, and we'll also be looking at nuclear material. Now, coal, oil and natural gas, in order to liberate the energy from those chemical stores, we must burn them in the presence of oxygen. This causes the release of carbon dioxide. Meanwhile, nuclear material, we liberate the energy from that via a process of nuclear fission, which we will look at in a future video. So firstly, we'll look at a couple of common misconceptions. The first one is that this image is often given along with talk and lines about pollution. However, the average person doesn't realise that those are not chimneys and that is not smoke. Those are in fact cooling towers, and what's coming out of them is water vapour. So unless you're terrified of your room being filled up by water vapour coming out of your kettle, then we shouldn't allow this image to scare us with the idea of pollution. The second misconception is that if a nuclear meltdown happens, you'll get a nuclear explosion. This is also not true. In reality, what happens in a nuclear meltdown is the nuclear material heats up too much. This causes it to burst the containment vessel, and nuclear material will be spread through the local area. It, however, will not cause a nuclear explosion. So the current global power supply has the majority produced by fossil fuels. Coal, oil and natural gas represent far more than 3/4 of the world's power supply. Meanwhile, in the UK, coal and gas represent more than 50%. However, do not represent more than 2/3. Meanwhile, nuclear and renewables represent a far higher fraction than the fraction that the world uses. So we'll look at how a coal, oil and gas power station works. So the first step is you take coal, oil or gas and you burn it in a furnace. This liberates thermal energy, which then causes water to evaporate and turn into steam. When it does so, it travels along a number of pipes and through a turbine. Once it reaches the turbine, it causes the turbine to spin, which then causes a generator to spin. Inside the generator is some magnets and some coils of wire, and when you have a coil of wire moving through a magnetic field, it produces an electric current. Now in this case, we do not have a cooling tower, we just have a river being used to cool it down. However, a lot of coal power stations, oil and gas power stations all use cooling towers. However, they also have chimneys through which carbon dioxide is liberated into the atmosphere. So the advantages of coal, oil and gas power stations is that they can work continuously. You don't need daylight, you don't need wind, you can turn them on and keep them going. The power supply can be varied to some extent depending on the demand. They can't be varied instantly as it takes a long time to increase the speed of the turbine and a long time to decrease it as well. And few power stations are needed to supply a large number of houses. Meanwhile, the disadvantages are the fact that you have to buy fuel constantly, so there's the cost of fuel. They also produce large amounts of carbon dioxide, which is contributing to global warming. They also produce other pollutants. So when we have coal burned in a coal power station, there are some sulfur impurities in that coal, and that sulfur, when it burns, produces sulfur dioxide, which leads to acid rain. Finally, fossil fuels will run out eventually, so we cannot continue using them forever. Now it's important to note here that the reason for the trend from coal to gas in the United Kingdom is because per kilogram, coal releases more carbon dioxide into the atmosphere than gas. That means in order to reduce the amount of carbon dioxide you put into the atmosphere, it is better to have more gas power stations than coal. Nuclear power stations. The way in which these work is almost identical. Essentially, we have nuclear material, which, because of a nuclear reaction, heats up. When it heats up, that causes water to boil, turn into steam, and then turn some turbines. However, an important thing to note here is that the water it initially heats is actually recirculated through the core. That water is never taken to either a reservoir, river, or the cooling towers. That water is simply recirculated inside the reactor vessel to prevent any radioactive material from leaking. Meanwhile, a heat exchanger is used, which sends the hot water into the heat exchanger, and that water then heats another amount of water. That water then travels down through the turbines, turning the generator. It is that water that goes back into the reservoir, not the water that is in the reactor itself. Finally, the advantages of nuclear are that they can work continuously. The power supply can be varied depending on demand. Few power stations are needed to supply a large number of houses, and they have an extremely high energy density. 1 kilogram of uranium can provide the same energy as 10,000 kilograms of coal. So they are far more efficient at producing energy for the amount of fuel you have to buy. However, disadvantages are that the cost of fuel is very high. Mining uranium and then enriching it to make it into nuclear material that can be used in a power station is extremely time-consuming and expensive. Another disadvantage is nuclear waste. The products of a nuclear reaction remain radioactive for many millions of years. Since radioactive materials are harmful to living creatures, they must be disposed of sensibly. Unfortunately, in the past, people just put them in concrete containers and dumped them in the ocean. However, today, there are plans to dispose of nuclear waste deep underground. This will reduce any risk of nuclear contamination of the food chains. Lastly, there is a risk of meltdown. Though the risk is extremely small, a meltdown can cause a huge number of deaths, large areas of land to be left radioactive for a long period of time, and that increases the chance of people in that area developing cancer.